Hey everyone, today we're going to be making another video game inside of Go. The game we're going to be making today is the infamous Doodlejump. Now, obviously it won't be as good as the original one, but it's usable. So here's a basic demo as to what we will be building today. Alright, so as you can see over here, you have this Doodlejump, okay? And once it hits a block, it'll jump back up. Now see these brown blocks? The way they work is that if you touch them, they disappear. And now, let's suppose if I just go all the way down and fall, I die. And it just tells the final score. Alright, so to build this, we're going to be using Raylib, as usual. Alright, and let's just first of all go over the basic rules of this game. So understanding the basic rules of the game is necessary in order for us to make the game. You are a character called Doodle. At least that's what I think you're called. Now, you can move left and right, but you're always falling down. Now, what you can do is step on these blocks that will help you go up for a limited period of time before you get jumped before gravity takes over and you go back down. Now, there's two blocks, a black block and a brown block. Now, the black blocks work is that you just jump off them and you can do that over and over again. However, the brown blocks are a bit different. If you step on them, they will break. Now, but you will still go up, however. Now, I know this isn't entirely the same as the original Doodlejump, but it's close enough. And the main purpose of this tutorial is just to get beginners into game development inside of Go. Alright, so let's just begin making Doodlejump. So before we actually start coding, one thing you guys always need to have is certain assets, right? So for this game, we're going to have three assets. We're going to have our background, alright, we're going to have our left player, and then our right player. Now all of this can be found on a GitHub link below, as well as the entirety of our code. Alright? So the first thing we're just going to want to make is our background. So the background is really just going to be there for the sake of, making our game more likable and attractable. So to do this, first of all, we're going to just go ahead and write package main. The next thing we're going to want to do is just go ahead and import Raylib. Alright, so in order to import Raylib, alright, and I'm under the assumption that you guys already have Raylib installed. For Go, at least. Now, if you don't have it installed, I'm going to show you guys right now. So first of all, you're just going to want to go get, alright, and then you're going to want to paste this link over here, alright, and you guys can just copy that down. So if you go on this link on the internet, it'll show you the Raylib documentation for Go, alright. Now, as you can see over here, it's already installed, so it didn't really do anything, alright. Now, what you're going to want to do, right, is just take this link and just paste it here to be imported, alright. Now that that's done, go ahead and create a main function. The main function is where the compiler goes to read code first. Alright? Now inside of here, the first thing we're going to want to do is just set up some screen basics. We're going to want to create a screen width and a screen height. Alright? So our screen width is just going to be, we're just going to go ahead and set that equal to 450. Now because Raylib Go is just a bunch of C bindings, we're going to have to use int32. So to do this, just write int32 and wrap that around your number. Alright, now we're going to do the exact same thing with screen height. Alright, and we're just going to go ahead and set that equal to, I'm going to go ahead and set that equal to 800 pixels. Alright, now that that's done, what we're going to want to do is go ahead and just initialize a window. In order to initialize a window, we're going to go like this. rl.initWindow, okay, and we're just going to write our screen width, our screen width, and then our screen height, and then we're just going to give it a nice title. I'm going to call mine Doodlejump. Alright, now that that's done, what we're going to want to do is just set up a target FPS. So the target FPS, what that allows you to do is just have a specific rate of frames running per second. If you have a really strong GPU, what's going to happen is that your game's going to move really fast. So what you do is you put a limiter on it, and this is what most video games do as well, in order to prevent your game from moving too fast, and as a result making your gaming experience much easier. So we're going to go rl.setTarget, and we're going to set target FPS to just 60. Alright? Now the next thing we're going to want to do is just go ahead and just create our for loop. So inside of our for loop, what we're going to want to do, right, is have a statement over here that goes for rl.window should close. Window should close. Okay, and all this is just going to go ahead and just check to see is if the window is closed or not. In the case that the window is closed, or in the case that the window is closed, or it's not closed, it's going to keep on running. But if it is closed, all we're going to want to do is just close everything. To do that, just write rl.close window. Okay, now inside of rl window should close, what we're going to want to do is just go ahead and start drawing. Begin drawing. The next thing we're going to want to do is just go ahead and end drawing right over here. rl.end drawing. Okay. Alright, let's see, what else do we have to do now? Oh yeah, now the next thing we're going to want to do is actually go ahead and load in our background. Now, for this background over here, we're going to first of all want to load the image, then we're going to want to convert it to a texture that can be drawn into our screen. To create a texture, all we have to do is just go background image, alright, and just go ahead and just use the declarative operator, and go ahead and just go RL. You're just going to want to go rl.loadImage, rl.loadImage, okay, and then you're just going to specify the path. So mine is just assets/background.png. Okay, the next thing you will want to do is actually just go ahead and resize this image. Now, if you guys haven't noticed this already, this image is really, how do I subtract? Nope. Okay, this is, one moment. Here we go, yeah. As you can see, this image isn't really that big. So there's two ways to fix this. One, what we can do is just, make a bigger picture. Well, that's kind of a Neanderthal solution, because what happens is that if the image itself has to be resized again, it won't work. Instead, what we do is we resize the image proportionate to our width and height. So what this does is it allows the image to be dynamically adjusted. To do this, just go rl.image resize, okay, and all we do is just go ahead and take the background image, okay, and then what we're going to want to do is just resize it to the screen's width and the screen's height. Now that that's done, what we need to do now is just go ahead and draw this texture. To do this, we're just going to go there. We're going to go rl.draw texture, and texture that we draw is just, we also need to now convert this over into a texture. To convert it into a texture, all we have to do is just go background, declarative operator, okay, and then we're just going to go rl.load the texture from the image, and then we're just going to put the image. So our image is just the background image. And then we're just going to go ahead and just load this background. Alright, now that that's done, let's just go ahead and run this. To run this, just go run main.go. Undefined. Load in line of arguments RL. Oh yeah, sorry. So we have to, in order to draw our texture, we need to first of all specify the background, or whatever image you need, or the texture you need drawn. We also need to specify the X and Y coordinates. So to do this, I'm just going to use 0, 0. That's because I want it to be spread across the entire image, or entire screen. And then we need to specify a color. Now, we don't really need a color, but we just need to have it specified. So just use rl.white. Now if we go ahead and run this, undefined, rl load text, load texture from image. Here we go. There we go. Now if I were to just zoom out, and as you can see over here, we now have our basic background screen. Now the next thing we're going to want to go ahead and do is just set up a character controller. Alright, so in order to create a character controller, the first thing we're going to want to do is just load in our images. So the two images that we need to load right now are the left image and the right image. To do this, first thing we're going to want to do is just copy and paste some work we've already done. So we've already loaded the background image, and we really just want to use the exact same concept for it. Alright, so let's first use the player left image. Alright, so I'm just going to go ahead and call this left image, and then we're just going to set it to the path of where the player left image PNG is located. Okay, now the next thing we're going to want to do is just go ahead and load in this image. To do this, I'm just going to go left character, all right, and just set that equal to, and we're just going to want to load the texture from the image of the left image. All right, now let's go ahead and just repeat this concept for the right image. All right, so we're just going to go right image, and we're just going to go player right. All right, and now we have both the right image and the left image created. Now you might be wondering that how are we going to map these two over and over again? Now this is where the middleman comes in. So the middleman is really just going to be a variable called character. All right, and it's going to be originally set equal to the right character, but as we move around the keys, it will constantly load in these two characters from time to time. So to do this, all we're going to do is, first of all, we're just going to go ahead and just make a brand new variable and call it character. All right, next thing we're going to do is just go ahead and set up the declarative operator. Okay, and we're just going to want to load in the right image for now. That's because the player will originally be in the right position. Okay, now let's just go ahead and draw this image onto the screen. To do this, you're just going to want to go you're just going to want to go rl.drawTexture, rl.drawTexture, and we're just going to draw over the character. All right, and oh yeah, we also need an x and y coordinate system for our characters, so let's just make that right now. X position, and make sure these are in 32s, by the way. Okay, and we're just going to want to go ahead and draw these X position and the Y position. All right, and then we're just going to want to put in our color, which is just rl.white. Does that make a difference? Absolutely not, but it's something you just have to do. All right, now that we've actually drawn this character to the screen, we really also want it to be able to move left and right. This is because in Doodlejump, the character is allowed to move left and right, and gravity takes care of the rest. To do this, we're just going to go ahead and make two listeners for the A key and the D key. To do this, just go ahead and type if rl.is key down. Okay, and so it's going to be the rl.key A. Now, in the case that it is down, all we really want to do is just take our X position, and what we're going to want to do is just go ahead and subtract 5 from it. And in the case that it's the D key, all we're going to want to do is just go rl.isKeyDown, and we're going to want to go rl.key, and it's going to be the D key. All right, and in that case, we're just going to take our X position and add over 5. Another thing we also need to do is just take our character and just set that equal to the left character. Otherwise, we're just going to set our character is equal to the right character. All right. Now, let's just go ahead and run this. To do this, we're just going to go run main.go. Left character. Can I use left character as RL duty as well as... Wait. Character... Okay, wait. So, we're doing... Oh, sorry. We're going to want to load image. Whoops. Character was originally supposed to be a texture, not an image. So to do this, all we're just going to want to go is just load texture from image as the right image. Okay. And then we're just going to want to run this. There we go. Now, if we just go over here, okay, as you can see, the character is now finally moving. So now you may be wondering, why isn't this Doodlejump falling? That's because we haven't done anything to the Y coordinates. To do this, all we're going to want to really do is just take this for loop that's just infinitely running. Where is it? It's right over here. And all we're going to want to do is right at the end of this, like about here, let's just do this right below here. We're just going to take our Y position and just subtract over 2 pixels. This way, it's constantly falling down, just like in the real game. Or wait, no, not -2, +2. There we go. There we go. So now, as you can see, Doodlejump is falling, finally. All right. Now, the next thing we're going to want to do is just go ahead and set up some simple, basic, borders, as well as make our basic platforms. So let's get into that. So the first thing let's just go ahead and do is just add up some platform or some borders. This is because the platforms will take a while and borders are much easier to implement. In fact, they'll be easier to do now than before. So to do this, all we really have to do is just add some more game logic inside of the character controller, which is really just two if statements. So for A always goes left. However, we don't want it to go left if the x position is first of all going to be greater than 400, and if the x position is greater than negative 30. Now I'm choosing negative 30 because the image size itself is about a nice chunk of it will be 30 pixels. This will allow the image to actually fit onto the screen because it's a bit big. And for the D position, I'm going to go ahead and actually choose. I also don't want the x position to be. I want to make sure that 400 is greater, and that the x position is greater than minus 30. All right. Now, if in any situation it has become greater, what would happen is that it would actually get stuck. Now, because it gets stuck, what we need to do is actually add some extra if statements that in those cases will get it out of it. To do this, there will actually be two cases. So first of all, if the x position, is first of all greater than or equal to 400, in that case, we're just going to take our x position and decrement 5. Similarly, if our x position is greater than, and if it's less than 0, we're going to want to take our x position and go ahead and add 5 to it. Alright, now let's just go ahead and see how this works inside of our game. Alright, so over here in Doodlejump, he can't seem to move. Yeah, so as you can see, he's just moving to the sides, but he's not crossing that section. Alright, now that that's done, let's actually get into a bit more of a harder part, the platforms. Alright, so let's first go ahead and just create our struct. The struct is just going to be for all of our platforms, and the main purpose of this is just to make the code a lot more neater and more organized. So go over here and just type in type. Alright, we're just going to call this a platform, okay? Now the platform is going to have 3 main attributes, alright? And just keep in mind this is a struct because Go doesn't support OOP. Alright, so it's going to first of all have our x position, which is an int32, a y position, which is also an int32, and a color. Now, as I mentioned earlier, if the color is brown, then it's going to last once and then it's going to break. So that's the reason why we really have the color. We're just going to check to see if it's brown, and in that case, it's going to break, and then it's just going to go back to the top. Alright? Now, the next thing we're going to want to go ahead and need is to go ahead and create a slice of the platform structs. Alright? So by default, I'm going to go ahead and have 5 of these structs. Now, the reason why for now I'm just going to keep in 5. Alright? This is just so that we can just test out to see if it's, overall working. And then later on, if we need to add more, we can go ahead and do that. So first of all, we're just going to go ahead and create a brand new variable, and that's just going to be called platforms. All right, and we're just going to go ahead and just do that right below the y position. So go over here and you just write platforms. Okay, we're just going to use the declarative operator to set this equal to a slice of platform. Okay, so now that this is done, all we're going to really want to do is first of all create a couple of platforms and then add them over. To do this, I'm just going to go ahead and type platform 1 declarative operator platform. Okay, we're just going to set this equal to 10, 100, and we're just going to set it equal to the color of black. Alright, so all we're doing over here right now is just creating a rectangle, or it's going to be a rectangle, okay, and we're just giving it its x and y coordinates. Alright, now let's just go ahead and make some more. So we have to make 5. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. Okay, now for the 5th one, we're just going to go ahead and make this rl.brown. Okay, so let's go over here. So we have 10, then we have 100, All right, and then we can have, let's see, we can have 300, I guess. Okay, and that's just going to be 300. Let's see, we can have 40 by 400, and let's just put 250 here by, oh, whoopsies, 250 by, well, 500, okay? Now, we need to go ahead and append these over to this main struct over here. So to do this, we're just going to go platforms is equal to append, and we're just going to want to append the platform 1, and we're just going to go ahead and rinse and repeat this for the next 5. Okay, now while we have all these, put out, what we also now need to do is go ahead and draw these over onto our screen. Now, in order to draw these over onto our screen, we actually have to do a bit more work. So first of all, we're just going to go over here, right below draw texture, okay? Well, let's just put this over here, yeah. Okay, and all we're just going to do over here is just make a for loop that's going to loop through every single one of the slices inside of the struct, okay, and just draw them. To do this, we're just going to go for underscore comma current platform, okay, and set that equal to the range of the platforms, okay? Now, inside of here, all we're going to really want to do is just go ahead and just draw the rectangles, okay? rl.draw rectangle, okay? And inside of this rectangle, all we're just going to draw is the current platform dot position x, current platform dot position y, okay? Then we're going to have like the size of it. So what I'm going to do is I'm going to have it with a width of 30 and a height of, or a width of 100 and a height of 30. And then we're just going to go ahead and give it a color, which is just going to be the current platform dot color. All right. Now that's, yeah. And there's no need to for any configuration for the color because they use the same color library. Now we can just go ahead and run this. Now, as you can see over here, we have all of these nice platforms. However, the issue now is that they don't really work. They're just there. So now the next thing we need to go ahead and do is teach it to collide with them, and also make these platforms fall down. So let's get into that. All right, so in order to check collisions, the way it works in RayLib is that you draw a virtual rectangle, or you make 2 virtual rectangles, one where the enemy is, or one where one object is, and one where the other object is. And you basically check to see if these 2 rectangles collide. In the case that they do, you can then add some functionality. To do this, all we're going to do over here is just go if RL, or let's actually remove that, if RL dot check collision rectangles, all right, and all we're going to really do is just make 2 rectangles. So we're just going to go RL dot new rectangle, all right, and what this new rectangle is going to do, right, is first of all take in our float 32, which is just going to be our x position. Okay, then it's going to take a float 32 of our y position. Then what it's going to do is take in the size of the character itself, which is this thing over here. Now, one thing to note here is that we're not including the nose, okay? We're just including this thing. So we're actually going to be making it a tad bit smaller. To do this, we're just going to use float 32, and we're going to use 53. All right, and we're just going to go float 32. We're going to do 120. Okay, now that that's done, let's go ahead and add in our next rectangle. Our next rectangle is just going to be the, what's it going to be? It's going to be the current platform at hand. So our new rectangle, all right, is going to first of all have in our current or it's going to have a float 32 of the current platform, and it's going to have its x position, and we're just going to subtract over 37 because of the nose. Then we're going to have our float 32, and this is going to be the current platform's y position, okay? And it's just going to be, yeah, and that's really all there is. And then there's just going to be of the float 32 of the 100 pixels, which is the width, and the 30 pixels, which is the height. All right. now that that's done, we're going to go ahead and just implement some, like what we're going to do now. Now, in the case that it is true, all we really just want to do, right, is just first of all take in our Y position, okay, of the player, and we're just going to want to increase that. So we're going to increase it by, let's just say 120 pixels. So let's just go ahead and run and see how that's like. Alright, I'm just going to go ahead and skip that. So yeah, as you can see over here, the Doodle jump just keeps on jumping upwards. Now let's see what happens when it hits the brown one. Now, when it hits the brown, we want it to break. Now, since it's not breaking, that's a problem. Now, let's go ahead and just fix that. To do this, all we're going to do is first of all just add in a brand new if statement. And this if statement will go ahead and check to see if our current platforms.color is equal to rl.brown. Now, in the case that that's true, what we want to do is first of all just take that rectangle, okay, and what we're going to want to do is just put it to the top. And the reason why we're putting it to the top, and we just want to reposition it, okay, and it's just going to come back down eventually later. The reason why we're not deleting it and making a new one is because that's just going to decrease performance, and we want our games to be high performant, even though you don't really need that much hardware, but it's just better practice. So, oh yeah, for this case, first of all, we also need to just import the random library. So go ahead and just import that. It comes with your system, if you've downloaded it Go correctly at least. So just go math/random, and you also need to import time. Okay. Anyway, back to the situation at hand. Where is it? Here we go. So inside of here, what we need to go ahead and do is, first of all, just set up a brand new x position for it to go towards. So let's just make a brand new variable here, position x, all right? And it's just going to be an int32. We're going to go ahead and just set that equal to an int32. And what we're going to want to do inside of the int32 is just go ahead and create a random integer. We're going to random dot int n, all right, and just set that equal to, now it has to be between the overall screen, the screen width, which is, 350, all right, but there's a couple of things we need to just take into consideration. The main one being is that the platform is about, it's about 100 pixels wide, so we need to just subtract over, 100 pixels, so that's just 350 pixels. All right. Now, another thing we also need to do is just initialize a time seed. What that allows you to do is actually just generate random numbers. All right, and it heavily uses the time library. So before we start the for loop, down here, let's just go ahead and, add in our time seed. So we're going to go random.seed, okay, and so we just take the current time.now, all right, and it's going to be .unix nano, all right? So now, okay, anyway, back to this. The next thing we're going to want to do is just go ahead and take in our current platformer, all right, and we're just going to take its x position and just set that equal to the position of x. So we're just going to go platforms at the index dot position x and just set that equal to position x. And then we're going to go ahead and just take our platforms at the y position and just set that equal to 0. Index dot position y and just set that equal to 0. The reason why we're setting this equal to 0 is because we want it just to go all the way back up to the screen. All right. So, oh yeah, and we don't have the index specified. To specify the index, we're just going to go like this. All right. And okay, let's just go ahead and see how this works so far. Okay, so currently he's moving. It's moving. Now watch what happens when it steps here. It goes all the way up. All right, and now what we need to do is for it to go we need these platform thingies to go down. To do this, all we're just going to do is just take platforms, okay, at the current index, all right, and all we're going to want to do is just make them go down by 1 pixel. And in this case, positive becomes negative because the canvas is inverted. All right, now here's how it looks. What's the issue? Dot position. Oh. Dot position y plus equal to 1. So all we're going to do here is just go run main.go. Okay, as you can see, these things are falling down. And one thing you might not have noticed, however, is that since they're falling down, they're not coming back up. So there's not really much for it to do. Now, in order to fix this, what we need to do is add some more if statements that check to see if the player is below the size of the the screen height. To do this, all we're going to do is make a new if statement, and actually, let's just add this over here. Okay, if the current platform dot position y is greater than the screen height, all we want to do is, first of all, we're actually going to go ahead and just yoink this from here. All right, and actually, let's just yoink all of this. Yeah, you just have to copy and paste all of that. That's basically all you do. Okay, now if we just go ahead and go over here, go run main.go. All right, as you can see over here, he's playing, he's having fun. Oh, guess what? See that one? Oh, it shows up right back up there. Now, another issue is that this guy, he can't go all the way back up there. Now, the way to solve this issue is just to have more obstacles. So currently we only have 5. So let's just go ahead and add 5 more. All right? Because even if you look in the actual Doodlejump game, there are usually like 5 to 10. I'll just add 8 because I feel like 10 would be a bit too much congested. So we're just going to go 5, 6, 7, 8. Okay? And we're just going to go 310. Actually, wait, no, that's not smart. Let's see. Let's go 450. And let's just put this in as about 600 because I don't see any 600s. Let's actually add another 450 and just add that over to 700. And let's just keep that as, I don't know, 750 or something. All right. Now, let's just go ahead and append these over. Okay, so we got 6, 7, 8. All right. Now that that's done, let's just see what happens. So over here, as you can see, it's moving. And oh, it needs to go back up. Now it can just stay over here. All right, now it's falling. Oh, there's a new one. Okay, it's just falling. Yeah, like so. So as you can see, we now have our basic game functionality created. And now I will admit it is a tad bit gimmicky, but I mean, you know, this was made in like 30-ish minutes. So yeah. So anyway, now let's just polish this game up by adding a scoring mechanism as well as an end screen. So let's first start off with our scoring mechanism. To make our scoring mechanism, first of all, we have to create a variable. The variable will obviously just be an integer, and we're just going to display that integer. I'm going to go var score, and we can just use that as an int. Okay. Now the way I want my scoring system to occur is if there's a collision. So there's 2 positions where there can be a collision. Okay, and actually there is one position. So if there is a collision here, we're just going to go score plus plus. The next thing we're going to want to do is actually import a string converter. This will allow us to display our string, or display our score as a string, because that's what we're going to have to need. All right. Now, the place where we're going to actually display our text is going to be, let's see, it's going to be, let's just leave it right at the top. So right about here. Okay. We're just going to go rl.drawText, and we're going to go ahead and go score plus, we're just going to take our string converter, okay, and we're just going to use and we're just going to go ahead and convert from integer. We're just going to convert the score, and it's going to be at the 0th terms. Alright? And then what we're going to want to do is just have a font size of 20 and just have it with black because black and green look well together. Okay? So let's just see how this looks so far. Okay, so as you can see, we have a score of 2, and as it goes down, it just goes up, and yeah, our score increases. Okay, now that that's done, the next thing we're going to want to go ahead and need is the end screen. Yeah, so the only way that the player can really die is if it falls all the way down. Alright, now it's pretty simple and straightforward to check in the case that that happens. So to do that, all we're just going to do is go ahead and, all we're going to do is just have an if statement right over here. So if the Y position is greater than the screen height, what we now need to do is first of all take all of our platforms, okay, and we're just going to want to set them equal to nil. Basically all that does is just deletes them from existence. The next thing we're going to want to do is just unload some textures. The textures that we're unloading is going to be the current player's texture. This way we can see it. Current player. Okay, the next thing we're going to want to do is just clear the background. rl.clear background. And we're going to clear it with rl.white. Next thing we're going to want to do is just draw some text. rl.draw text. And it's just going to be your final score is, and it's just going to have the final score, string convert dot score. And it's going to be at the positions of 30, 40, with a size of 30, and rl dot black. Okay, and yeah, that's basically it. Alright, so let's just go ahead and see this game now. Undefined current player, wait, what's it called? Wait, no, it's not current player. Sorry, character, yes. I made a small mistake. I accidentally called it current player, where I should have called it character. So we're just unloading the character at hand. So all we're going to do is just go run main.go. Okay, now as you can see, you're playing, you're having fun. Oh, what's that? Oh, you slipped? Oh, you're slipping again? Oh, you fell. Well, now it shows that your final score is 3, and the game is over. If you can't tell by now, that's basically how the game works. So yeah, that's it. If you guys have any questions, leave them in the comments below. Thank you guys for watching. Have a nice day.